Go ahead and start the warm-up. Try those problems on your own. Pause the video. When you come back, you'll see your answers. All right, there you are. Remember, multiplying or dividing by multiples of 10, so 10, 100, 1,000, is just moving the decimal that many zeros spots. So for example, if the number is 123, if we multiply by 1,000 like we did in the first problem, that's taking your decimal, and since there's 3 zeros, moves it 3 spots. 1, 2, 3. So decimal goes there, and then you add those 3 zeros. If we divide by 1,000 though, once again we've got 3 zeros, so we move the decimal 3 spots the left way to make the number smaller, because dividing makes things smaller. 1, 2, 3, and we get 0.123. Same thing is true for 3 and 4. If we look at the table, it shows the relationship between several powers of 10. So let's start with the stuff we know. We know that 10 to the first is just 10, and anything to the 0 power, so 10 to the 0 has to be 1. And if we keep moving here to the left, 10 squared is 100, and 10 cubed is 1,000. So once again, powers of 10, all we're doing is we're just moving the 0 or the decimal over to the left or to the right. So 10 to the negative 1 also works that same way. Remember, a negative exponent flips the fraction, so it makes it, so 10 to the negative 1 equals 1 over 10, which as a decimal, that number is just 0.1. 10 to the negative 2 is going to be 1 over 10 squared, which is equal to 1 over 100. Let me make that 10 squared a little bit better. 1 over 100, which is 0.01. 10 to the negative 3. If we follow the pattern, we just move that decimal over 1 spot. So you take your decimal, you just move it over to the left. So 0.001. All right, so in our notice anything here, we can take a look at what we've got. So each time you divide by 10, the exponent is going to decrease and the decimal moves 1 place to the left. So if I take a look at just these 2 columns, so we've got our 10 cubed and our 10 squared, which is 1,000 and 100. So if I go from here to here, notice that my exponent is decreasing, right? The exponent is a 3 here, and my exponent is a 2 here. So the exponent is decreasing. When I divide by 10, exponent decreases, and the decimal is moving 1 place to the left. Because notice how we had the number 1,000 with our decimal right here, and then it moves 1 place to the left to become 100. And notice when we multiply by 10, it's just the opposite that happens. So, right, if I multiply by 10 and I take the number 100 and I multiply by 10, we get an answer of 1,000. So each time you multiply by 10, the exponent's going to increase because we're going from 2 to 3. And then the decimal is going to move 1 place to the right. So we had the number 100. We multiplied that by 10, so then our decimal is going to move 1 place to the right. And we add an extra 0 to make 1,000. So if you look at this table is extremely helpful. So quick pause the video, take a look at it. And that's going to help us kind of know how we should move our decimal. For me, the kind of way I think about it is if we have a positive exponent, it's going to make something bigger. And if we have a negative exponent, it's going to make something smaller. So if I have the number 10, and I want the number 10 to the 4th, well, then I know that's going to make the number bigger, so I need to move the decimal to the right. 1, 2, 3, 4 spots. And then I fill those 4 spots with zeros. And so I get the number 10,000 with 4 zeros after it. Mistake time. Okay, 10 to the 4th. means that we're going to have 4 zeros, that number gets bigger. So we get up to 10,000. And if the number is 10 to the negative 6, that negative tells me the number is going to be small, which means we're going to have to take a number and we're going to make it smaller. So we always start with 1, and we're going to move that decimal 6 spots. So you should have a 0, a 0, a 0, a 0, and a 0. So 0.00000. With positive exponents, we're going to have that many zeros. With negative exponents, that's also going to be true if you put that 0 out in front. So I have 6 zeros. You'll see 1, 2, 3, 4, 5, and 6. All right, and here are some practice problems. Do your best to do these without a calculator just so you can get used to how they work. I'll do some of them with you. I'll do 1 and 4 for both of these, and then you do the rest on your own. Actually, I'll do 1 and 2 for both of these. So let's start out with the first one. Find the value of each power of 10. So for the first one, 10 to the negative 6. So two ways of doing this. One, if you want to, you see 6 zeros. So you're just going to put down your 6 zeros. 1, 2, 3, 4, 5, 6. And then a 1. And then you put your decimal down right there. Okay. Or take your number 1. 1.0, right? Just 1. And then move that 6 spots to the left since we're getting smaller. 1, 2, 3, 4, 5, 6. And that is my number. Okay. 0.000001. 0.000001. Okay, 2 approaches to that. Number 2. All right, so for number 2, I'm just going to write it over here, 10 to the 4th. So remember that is taking the number 1.0 and moving it 4 spots, 1, 2, 3, 4. Or just think of the number as 1 and then 4 zeros, 10,000. Either one of those are correct for number 2. All right, try the other 4 on that top part on yourself. So 3, 4, 5, and 6. Pause the video, come back, and you'll see the answers. All right, so for our answers for number 3, we have the number 1 billion, which is going to have 9 zeros. 10 to the 9th is going to have 9 zeros. We have 0.01. 0.01. So we move that decimal, or we have 2 zeros with our decimal right here, or move that over 2 spots. Number 5, 10 to the 5th. Okay, 5 zeros, so the number 100,000. And 10 to the 10th is 10 zeros, so 10 billion. 10 billion right there. For next part, now we're going to go backwards. So we want to write our answer so it looks like something like this right here. So 1 million is going to be 10 to the 6th power. I know it's 10 to the 6th because it has 6 zeros. Okay, notice if the number is 1 million, then that means I have to take this decimal and move it 1, 2, 3, 4, 5, 6 times. So therefore it has to be 10 to the 6th in order to get us that decimal 1. Number 2, it's going to be 10 to the negative. First of all, I know it's going to be negative because my number is smaller. It's got that decimal in it. And then I count 4 zeros, so 10 to the negative 4th. All right, go ahead and try those other 4 on your own. Pause the video. All right, so for answers, we have 1,000 equals 10 cubed, so 10 to the 3rd power. We have number 4, 10 to the 8th. I count 8 zeros, so 100 million. 10 to the negative 5, and 10 to the negative 1. Just FYI, as you're putting these into Schoology, on the LT check or anything you do, you want to use the caret button, which looks like that. Should be Shift 6 on your keyboard. So you'd enter the number 10 cubed as 10 shift 6, then 3. You'd enter the number 6 if you were doing this as 10, shift 6, negative 1. All right, if you need any of this, go ahead. I'm going to erase some of that bottom row so I can write the definition of scientific notation. All right, scientific notation is a method to write really big or small numbers easier. From our early example, 10 to the 10th power, this is not exactly the most fun number to write down, right? That's a lot of zeros that you're adding, making sure you don't make a mistake. So for example, it's much easier to write 10 to the 10th rather than write the entire number out. So scientific notation allows us to take any number, not only powers of 10, and write them in scientific notation. If Jupiter's orbital speed is 1.3 times 10 to the 4th meters per second, how fast is Jupiter moving in standard notation? So in order to do this, we want to take our number, which is 1.3, and if we multiply it by 10 to the 4th, are we getting bigger or smaller? All right, and that's going to be a positive exponent, so we're going to get bigger. So that means we're going to move our decimal to the right. 4 spots. 1, 2, 3, 4. So our new decimal goes there, fill in all the remaining spots with zeros, and that is our answer. So 1.3 times 10 to the 4th is going to equal 13 and then 3 zeros. So 13,000 meters per second. All right, and last question here. We want to order these from least to greatest. Is a typo on the notes. Doesn't necessarily need to be a typo, but just for sake of this being the problem, get rid of that decimal. Should just say 5 times 10 to the -5th. It doesn't change our answer any, but I don't want to overly complicate the problem. So we have these numbers, so we want to put them from least to greatest. So hopefully the smallest one should be popping out at you. The smallest one is going to be the most negative exponent possible. So since there's only one negative exponent, this one should scream out at you as the least. So we're going to put 5 times 10 to the -5th as our least biggest number. Then we look for the next smallest exponent. So if there were any -4s, -3, -2, -1 zeros, we'd want to put those. There aren't, so we keep moving into positive numbers now. Because remember, this number is 0.00005. And that's going to be much smaller than any of these other numbers. So the next thing we look at is I see that I have 2 exponents that are both 5. That makes this problem a little bit challenging, but if those are tied, then we need to make sure that we are looking at the number in front of the decimal. Which one of those is least? Is 5 smaller or is 6.9 smaller? Because remember, these two numbers are going to be 5 and then 5 zeros. 1, 2, 3, 4, 5. And this one's going to be 6.9 and then move that decimal 5 spots. 4, 5. So I have the number 500,000 here, and then I have the number 690,000. So for this one, because the 5 is smaller than 6.9, that's going to be next. And then that leaves us with just one left. This one's going to be the biggest. It's got the biggest exponent. So 6.9 times 10 to the 11th is going to be the greatest one. So anytime we're ordering from least to greatest, the first thing you want to check. So our kind of rules about this is the first thing we want to look at is our smallest exponent. So find whichever number has the smallest exponent. In this case, the -5 was the smallest, so that meant it was our least. And then if we have exponents that tie, then we look at the number before the 10. So for example, we had an exponent tie here. They're both 10 to the 5th, so we look at the number that comes before the 10. So this was a 5, this was a 6.9. 5 is smaller than 6.9, so 5 becomes 5 times 10 to the 5th is our next smallest, and then 6.9 times 10 to the 5th comes after that. Apologize for the long video today, but make sure you're doing the practice, getting through this, then go ahead and do that LT check that we have for you as well. We'll be doing an activity on this tomorrow.